All right, welcome to our June 2020 user group session on ControlLogix. My name is Wayne Welk, and I'm going to just kind of introduce the topic here and turn it over to our guest speakers in just a moment. So first, welcome to our seminar, and just a few reminders that all attendees are muted to just kind of keep the background noise down. So please ask any questions in the Q&A panel or in the chat panel. We have a bunch of specialists in the background who will be monitoring that, as well as our two guest presenters who I'll introduce in a few moments. And a reminder that our sessions are recorded, and we post those recordings to our archive pages and our YouTube channel, so you can always catch these recordings after the fact if you want to go back and watch it again, or if you happen to miss one of our sessions. And as always, we want to thank you for attending and taking the time to join us. And we always welcome your feedback, and we encourage your comments, both positive and negative. We'd love to hear them all, and any ideas for future topics would be, we always love to hear that as well. So just a few upcoming sessions that we always like to highlight what's coming up. And Thursday, so our next user group will be in July. Of course, we do user groups monthly. So Thursday, July 16th, and our thinking for that topic is actually a discussion around the My Rockwell automation portal and the new software portal. So there's going to be some changes in how software is purchased with Rockwell. So we want to show that to our users. August is open, so that's, again, some feedback there would be great to hear if you've got a topic in mind. And then with the release of Plant PX 5.0 in September, we'll do a topic on that in September. And then Tech Talks are continuing as well, and those are usually a weekly event, sometimes more than once a week. And we'll end our networking series next Tuesday, part 6, with a SIP security discussion. And then we'll move into some other topics, such as signal conditioners and intrinsic safety barriers, and even ADC, or automatic device recovery, with PowerFlex drives there on July 1st. And one more thing, we've been doing a lot of online seminars over the last 2 months, and we appreciate everybody's joining us for all these. And we've created a lot of content, not only in the last 2 months, but over the last several years as well. And a lot of times we don't really show or talk about how where all this content's at. So there's a lot of digital content out there, and it's all kind of based. ReynoldsOnline.com is kind of the hub for a lot of this. We have all of our user group archives. Even going back to like the year 2015, we've got archives going that far back for New Orleans and Houston, as well as all the ones we've been doing as a combined team over the last couple of months. All of our Tech Talk archives. We even launched a podcast over the last 2 months, and available on all the most common podcast providers: Apple, Spotify, Google, etc. The podcasts are pretty nice, but right now we're doing a networking series, which is kind of goes hand in glove with the Tech Talk webinars series that we've been doing. Again, we have a YouTube channel for the Reynolds Company, so technical support videos and all of our recorded sessions are there as well. We have a blog, which is full of technical support articles and new product news. And then, of course, social media channels to follow us there as well. So just to highlight, to find all that content, it's out there, and so we hope you get to use that. And with that, we'll introduce our two guest speakers today, both from Rockwell Automation: Christopher Jackson, technology consultant, and Luis Ramos, solutions consultant. And if I got your titles wrong, please correct me there as you start. Just one quick note on the topic. We are talking ControlLogix redundancy, and we were going to highlight L8 redundancy, which we will do. We originally scheduled this topic here in June. That was kind of the original launch date for the L8 redundancy. That's kind of pushed out a couple of months. So today we'll be a little ahead of the game, but a good sneak peek perhaps, or a preview of what's to come here in the next couple of months. So with that, I will turn it over to Chris or Luis.
Sure. Good morning, everyone. I'm Chris Jackson, and as mentioned, I'm one of the technology consultants for Rockwell Automation in the Houston area. and I look forward to talking to you today with regards to Studio 5000 versions 33. Next slide, please. So when thinking about Studio 5000 version 33, there's three primary areas of focus there. Those being process applications, productivity enhancements, as well as hardware support. Now, from a process space, for version 33 of Studio 5000, they are taking a very aggressive approach on making sure that we are hitting this market head on, just as equally as we do discrete and hybrid markets. So things ranging from your embedded process instructions to highly integrated HART are new features that you'll see in version 33. From a productivity enhancement space, having automatic diagnostics, as well as like the data preserved downloads and even extended tag properties would be key focal points there. And from a hardware support space, being able to support the 5580 controller redundancy as well as process controls. Next slide, please. And again, these are just major touching points to look over when looking at version 33 and even the 5580 itself. And those range again from the architecture's compatibility, enhanced productivities, and high performance space. Next slide, please. So jumping right in, want to kind of start by looking at highly integrated HART or HART integration. So with version 33, when looking at Flex 5000 and HART IO on Studio 5000, you can now see this IO from the IO tree itself. In comparison to previous versions, you would have to go in through the add-on profile, and then it would be hidden in the channel. So now having that direct access to kind of see it right then and there is something that is kind of premiered to version 33 of the platform. And where you can see this kind of being beneficial is one, as kind of noted here, it's less programming time that's spent trying to configure these devices, and it won't be as meticulous as having to go through the add-on profiles again and do this one by one for each particular IO that you're trying to enable here. And secondly, it brings a familiarity to the browsing method of HART devices that's native to the Logix Designer application itself. Next slide, please. Secondly, when looking at the function block functions, function block came out in version 32 of Studio 5000. And in version 32, it was partially a full set, but now through version 33, the functionality of function block is fully enabled. So you would see things such as move logicals, advanced math, trigonometric data conversion function sets, and many other things from a visual output perspective that wasn't previously shown in the former. So overall, the main thing to pull from the function block functionality in version 33 is one, you have more visuals and you have a memory as well as visual footprint where you could make troubleshooting slightly easier through symbolic representation instead of just kind of having regular functions with no type of coherentness to it. Next slide, please. Now, when thinking about the add-on instructions, extended tag properties, what's different than the previous editions when thinking in version 33 here is now you can include the metadata in your add-on instructions. Now, in the previous versions of Studio 5000, you can only include these things in the tag space. But now in version 33, again, it's pretty pivotal because you can include additional information from the add-on instruction. Now, this idea for including additional data started back in version 21 of Studio 5000. So it's kind of a continuation moving on from here. But you would find this very beneficial if you had things such as engineering units that you wanted to include on into your add-on profiles, or even placing URL links or additional information from the label or library. So you can kind of contextualize and bring in more value into detailing out to whoever else may be later on seeing your code, what all is going on there. Next slide, please. And just as so, the capability of using the extended tag properties metadata is a feature that's in the alarms messages as well now. So again, contextualizing that data and kind of taking out the guesswork when diagnosing and troubleshooting by having that additional information there is pretty key. And also a pretty interesting thing about the extended tag properties is that the metadata does not take away from your overall memory usage. So you're not penalized through using it since it goes into the non-volatile portion of the controller itself or your processor itself. So through including this information, you're not going to be placed at fault. Next slide, please. Now, when thinking in terms of automatic diagnostics, through just a simple click of enabling the automatic device diagnostics, you can save yourself around 10% to 15% of engineering design time. As in previous times where, you know, again, you had your engineers who had to put a lot of time into writing code that was spent into locating errors in your alarms. You don't have to do that anymore. It's going to be automatically done for you. So that major reduction in time space is one of the premier things to look at there. Furthermore, you have this capability not only through version 33 of Studio 5000, but also through your Vue SC version 12 projects. Now, it is important to note, though, with the automatic diagnostics, again, that it's going to be key to FactoryTalk Vue SC versions 12 or higher, versions 33 of Studio 5000, and also that it's only for your IO and in specific for Flex 5000s, so the 5094s, your Compact 5000s, which are your 5069s, and your 1756 IO for the ControlLogix platform. Next slide, please. From a productivity enhancement space, some of the key features that you'll see in version 33 is that you can now write the name of the task when you add the time scan rate. So you no longer have to manually have like an underscore and add in to your program description or your task description, name the amount or scan time that is included with it. Once you create the description name to your task, that scan rate will already be automatically included now. So this will pull away from having the confusion of, you know, having the scan rate that's listed in your product description name manually being different than what the actual scan rate is itself. Secondly, you now have web page configurations. So now you can avoid programming web page configurations and instead just either enable or disable the controller web pages from within the controller's properties. And now with version 33, your default communications module will be FactoryTalk links. You still do have the option to utilize RS Links Classic if you choose to do so. However, what will be default to the system for version 33 is FactoryTalk links. Next slide, please. From the data preserved download, one thing to take into account here is this originally came back out in Studio 5000 version 24. However, where version 33 differentiates itself from version 24 is with version 33, the overall content for the data preserved download is embedded into the native system for Studio 5000. In version 24, you would have to download it as an optional separate tool. However, now it's native to Studio 5000. So you no longer have to worry about having to go in and do that separately. Next slide, please. That's pretty much things to look forward to from version 33. And again, I'm Chris Jackson. And if you have any questions, please feel free to place them in the Q&A. Thank you.
Okay, appreciate it, Chris. So that was a little bit on V33 release, as mentioned, and it was asked in the question. So V33 is currently set for August 2002 or 2020, sorry. So we will look for that. It was slightly delayed. Originally, it was around the April-May timeframe. Redundancy for the L8 was actually planned to be a separate firmware update. So at this point now at the August release, both of them will release at the same time. Kai, you're asking if the automatic diagnostic will be part of the L7. It will only be part of the L8 system. So we'd be looking at the 5380 for ControlLogix and the 5580 for the L8 style controllers, plus the new IO, so Flex 5000, Compact 5000. So what I'm going to cover is ControlLogix redundancy. So I'll touch on the L8 redundancy specifically on the first couple of slides, and then I have a couple of slides that are just generic for redundancy itself regarding configuration, application set, how we would go about doing the network design. As you guys have questions, feel free to fill them in. And if I don't answer it as we go through, then we'll make sure to answer it at the back end side of it. One of the things that we generally talk with customers around redundancy is if somebody comes to us saying that they have an application with redundancy, the main thing that we generally have to do from either the specialist or on the Rockwell side is ask redundancy for what system. So as you can see kind of in the slide here, we'd be looking at the ability of being able to do virtualized servers. So from a virtualization standpoint, physical servers, redundant switches, the ability of being able to do network redundancy. So that may be either redundant or resilient networks in talking about device level ring, PRP networks, ring topologies within the switch, IO redundancy, so using either 1715 or some variation where we can use that for a highly available system. And in this case, we'd be looking at controller redundancy, actually having two separate chassis within that purview. So just be aware that if one of the main things that you'll probably hear your account manager or anybody on the Rockwell or Reynolds side is if you ask for redundancy, we will push back just to understand what kind of redundancy you guys are talking about. So for anybody that isn't comfortable with it, so when we start talking about controller redundancy, we are talking ControlLogix. So that is our chassis-based design. Typically, this has been done with the 5570, so what we call the L7 processor. As of V33, we will incorporate the change so that we now have the ability of being able to do the L8 or the 5580 catalog string. When we are talking redundancy and we are talking ControlLogix, we are able to do a majority of our work while we're online. So just a quick, I'm not going to go through all of this, but essentially this is showing you what you can change and edit while you're online without actually having to stop the controller, without having to go into program mode. So you do have the ability of adding and removing IO online, specifically adding more than anything else. So the changes that you're seeing from the automatic device diagnostics, adding IO cards, looking at your controller diagnostics, making online changes to the controller code, potentially even upgrading firmware. We have that in the release notes on being able to update the firmware and the controller code for a redundant ControlLogix system. There is a method where you have to break redundancy from your primary secondary, but there is a method of being able to do that without having to bring down your system. So if you haven't seen that, it's part of the knowledge base articles and also the release notes. And then as we start looking at the automatic device replacements, disaster recovery, all of that is available while you're online. So similar to what Chris was talking about, even with the preserved download, those are part of those type of systems. So if you're not aware of it, take a look at some of the manuals and knowledge base articles that we have out there, or just ask one of us. Again, as of August timeframe, with the release of V33, we will be looking at adding the 5580 or L8 processor as a redundant option. It will follow suit very similar to the L7 architecture design. So the way that we handle the two separate chassis, the communication modules that we're doing there, the manner in which we do the switchover, the RM2 modules, which are the redundancy modules for ControlLogix, those stay the same. So it is still the 1756 RM2. And the way that we handle node count is handled via the type of controller that you're using in an L8 style. So depending on the specific 81 to 85 processor, it will tell you and designate the number of nodes. There are a few changes. A majority of this is based off the technology of the L8, but we'll kind of go through that in a little bit. And like I said, if you guys have questions, feel free to type them in and we'll have some time at the end. So similarities between the L8 versus an L7 style design. An L8, as mentioned, still uses the same RM2 module. So we would be still using the exact same configuration. Realistically, the only thing that would change from an L7 design to an L8 when we're looking at the chassis A and chassis B is the fact that it's a different processor. So the configuration is still done through Studio 5000. Nothing has changed there. Obviously, we'd be looking at Studio 5000 version 33. We can still support up to 7 communication modules. I have a couple of slides that show some examples. Generally, we're looking at least 1 communication adapter for upstream communication and up to 6 communication cards that can be handled via the IO communication, whether that's PRP, DLR, or standard star. Couple of the improvements and changes. So when we were looking at an L7 style design for redundancy, one of the big things that we would do via IAB, Integrated Architect Builder, is when you would build up a system estimation, if you were looking at redundancy, we would have quite a few documents that would tell you not to go above 50% memory and CPU utilization when you're doing redundancy, because it would take a hit and essentially double the amount of memory required when you're using the 5570. That goes away as of the L8 style design. So when we're looking at that, one of the big selling features that we've had with the design change for just a simplex L8 5580 ControlLogix controller is the fact that you can use up to 100% of your memory, because all the communications and everything was handled off the separate core. So one of the things that we look for here is also the ability of being able to now take advantage of that even during redundancy. So on a redundant system, you're looking at virtually doubling the amount of memory that you have available to you in an L8 style. We will now also support the Flex 5000 IO. So the Flex 5000 IO was introduced and used in terms of the 5580 controller in a simplex design. We now can use that for redundancy in a redundant architecture. So that could be the option there. It will still support a majority of the other IO. The next slide will talk about some of the things that we have to watch out for. As we look at it, one of the things in the past that you have usually seen is two separate firmware versions, one for redundancy and one for standard firmware on the controller. That goes away as of version 33. So what you'll see is that 33.011 that you see on the screen, that will be the same for both a simplex and a redundant controller. So we're kind of going away with that is essentially just a checkbox inside of Studio 5000. The other big thing that you will start seeing as of version 33 and with Plant PX system release 5.0 that Wayne mentioned earlier, that'll be coming out in September timeframe after the V33 release. Once that hits, you will also see a new processor come out to the market. The process controller, the P controller, which will be an L8 style design. So just as an FYI for everybody listening, you will have the option for L8 redundancy, both for the standard L8s that are out now and have been already on the market, and also for the process controllers that'll be out in August. We'll have more information on those as we get a little closer and when we do a full rollout for the Plant PX system release, but just be aware of the fact that you'll be able to do either or. So some of the things to be aware of, especially upon first release. So again, once the 5580 has redundancy capabilities on it, the L8 has an Ethernet port on the front of this. In terms of redundancy, when we're looking at using two separate chassis in a redundant architecture, that front port is turned off. So we will not be using that as an uplink port or for IO. We would essentially just choose not to use it. So just be aware when you're looking at these newer designs, again, it will match very similar to what we're doing in the L7 ControlLogix family, where that front port will be turned off. Upon the initial release, we're not going to be supporting SIP security directly to a redundant platform. So we still support it in a simplex design. So both the L8 and also the EN4TR adapter both support SIP security. So this is the ability of being able to do encryption level to the IO and to the controller and also to the software. In redundancy, that will not be supported. So just be aware of the fact that that won't be part of it. So if that's a requirement, talk to me or somebody else and we can look to see what the options are. We will not be supporting upon first release 5069. So I mentioned Flex 5000 will be a supported IO. The Compact 5000, so what sits with the 5380 IO, will not be supported. You can still do producer consume to the 5380 or other controllers, but you would not be able to put the IO directly onto a redundant L8 platform as part of the device level ring or any other network design that we're doing there. For legacy communication, if we're dealing with ControlNet, DeviceNet, DH+, RIOs, or the older controllers, that will not be allowed directly on a L8 style design. So we would still have to use either a simplex L8, tie that in and do producer consume, or we'd be looking at tying in with staying with an L7 style design for ControlLogix on this. So just be aware when we're looking at that, that is something that is supported in the L7, and I'll talk about that in a couple of slides. But in an L8 design, we will not be able to incorporate DH+, RIO, ControlNet, or DeviceNet. And one other change that may or may not be a little different than what you guys have been used to is generally speaking in an L7 style design when we had two separate chassis. One of the options that we've had for quite a few years is the ability of being able to tie in two controllers. Now, in a plant PAX style design, we will tell you not to do that. We generally, in our documentation for a process-based system, we would say just one controller per chassis, but from a technical point of view, we did have the ability of supporting up to two controllers per chassis in an L7 style redundant platform. Going forward with an L8 style design, we will only be supporting one 5580. Essentially the amount of data and throughput requirement through that RM2 module, through the communication module, because of the fact that it's a faster controller, we're limiting that upon first release to one single controller. So a single L8 redundant pair per chassis. If you need to support multiple redundant controllers, you would just need multiple redundant chassis. This is a quick graphic just for you guys to be able to kind of see some of the differences and similarities as we see. The 5570 refers to the L7 ControlLogix. The 5580 would be the L8 style control. So future, again, the two processors in the same chassis. Everything else is essentially the same. Sequence manager support will be in a future release. So that'll be a firmware and update to Studio 5000. Again, Ethernet IP support, that's all there. We will not be supporting in an L8 style control net, device net, as I mentioned, or the legacy network protocols or processors. The future for 5069 with that unicast connection, that will be in a future release. Either of those, as you guys are aware, if we're looking at an L8, they support the 5094, which is Flex 5000, and also the Compact 5000. You are not able to communicate with an L7 in the first place. So Simplex still works, but if we're looking at redundancy, the 5069 will be a future edition. If anyone is still interested or looking at a SIL2 process safety solution, our response there is still for now going to be a L7 with 1715. That SIL2, the TUV certification, the method that we use for the reference architecture and everything there is still in an L7 design. So just kind of be aware of that if you are looking at that. And then obviously the SIP security, the embedded Ethernet port, the support for gig, it would all be future. So as of the first release, the architecture that we would see, this is an option for one. The initial chassis, so the chassis A, chassis B for the L8 would still support the EN2TR, 2P, 2F, all of that. The EN4TR, which is the newer communication adapter, upon first release at V33 will not be supported in the redundant chassis. You can use it as a redundant IO or in your remote IO chassis as we see in the picture. So this is just showing an EN4TR. If you guys have seen this in conversations that we've had in the past, this is supported for device level ring, gig communication when we do PRP or parallel redundancy. And the latest firmware that we're going to be seeing at the in the summer time frame is also the ability of being able to do redundant adapters. So from a adapter point of view, this is no single point of failure. We can add two Ethernet adapter cards into these remote chassis and do either the parallel redundancy or the DLR through this, and it would be handled via code. You essentially wouldn't have to, it would be part of the code itself. You wouldn't have to create any customizable code to have this do the swap over. And as somebody elegantly pointed out, if you are doing redundant adapters, more than likely you also want redundant power supplies. So make sure to be aware of that. Thank you, Brian. The other thing that we'll see again with the L8 style design, so again, as part of the V33, is we'll have support for PRP. So parallel redundancy was introduced back, I believe it was around version 30. We introduced redundancy support within L7 style controller as of version 31. So what we'll see here is the ability of now within L8, we'll be able to support the Flex 5000 design, and Flex 5000 has the ability of supporting both device level ring and parallel redundancy. So if we're looking at this, you'll now have the ability of being able to support it on both. If you're looking at the L7 design, you'll be at version 31. If you're looking at the L8 style design for ControlLogix, you'll be looking at version 33. So all of that was specific to the L8 style. So as we go through ControlLogix, like I said, we'll have the L7 and L8 as of version 33. It will support both. Let me take a quick second to look at some of the notes that came in just to make sure before I just do general communications. Roadmap for the embedded port for redundancy on an L8. It is on the roadmap. I don't have a specific date on when we'll see that, but that one is a future, as I mentioned on the slide. PLC 5 slick mapping, as I mentioned. So what we'll do there is we can still do producer consumer messaging. We just, in an L8 ControlLogix design, we will not be able to put that as directly into the IO. So we would still have to have that IO mapping at another controller level and then do communication from that. As with anything, especially when we introduce the L8 in the first place, one of the things that I would always tell you guys is you can support an L8 and an L7 on the same system. So just be aware of the fact that as we start doing phase migrations, modernization systems, we have the ability of essentially upgrading the top end design and slowly phasing everything that we have underneath it. It may require additional controllers. It may require the ability of changing how the network design is, especially when we're going from ControlNet to something like Ethernet IP. So in those instances, just get with us. I'm a huge fan of napkin note drawings to be able to kind of review what you guys are going through. In terms of, general guidance for ControlLogix redundancy as we see fit. We will see a new update to the manual as of V33. So that'll introduce the L8 into the manual setup. Right now, if you download the manual, everything is based off an L7 platform. The support that we have for a redundant chassis, as I mentioned, we can support up to 7 communication adapters with 1 controller. In terms of an L7, you can support up to 2 controllers in the same chassis. So we have the EN2Ts, EN2TRs, the fiber module, the parallel redundancy, which is the 2TP, and of course the extended temperature modules. If we are doing the parallel redundancy, we need to be at minimum version 31. If we are looking at the EN2T modules, we'd be kind of pushing you towards version 20. As of right now, the versions of Studio 5000 that still support redundancy, 20, 24, 30, 31, 32, and will be 33. If you are incorporating into a newer system, a lot of the times we are still looking at version 20 as our gold release when it comes to support for the L7, L6 family. As you know, ControlLogix L6, even though it is end of life, they can go up to a max of version 20. The L7 could go down to version 20. So if you're still handling a customer that has legacy support, 20 is still an available option. If we have the ability, we'd start looking at introducing a change to go up to version 31, 32, 33, respectively, depending on what your situation is. Obviously, an L6 can't go that low, but an L7 can go up. So if you have those type of questions, feel free to reach out to us and we can kind of give you some recommendations one way or another as we go through. So this would be, again, specific to an L7 style design for ControlLogix. This is the idea where we could support DeviceNet, Rio, DH+, and Modbus directly through the chassis. It would be bridged. So as you can see in the drawing, redundant processors, redundant power supplies, I/O handled via an EN2 or 2TR in device level ring, and then you'd have your DeviceNet, Rio, everything in there. So you are able to support that. So this is a bit of a busy slide, but I wanted to kind of add these in as recommendations on how we would look at an overall architecture. So for anybody, again, that hasn't seen redundancy, we deal with a 2 chassis-based system. So what you would have your controller, your redundancy module connected via fiber. It is 2 fiber drops. Essentially, you can design 2 separate paths for your fiber. So the ControlLogix chassis A and chassis B do not have to be within the same panel. They don't even have to be within the same building, as long as there's a connection between those fiber connections and you have power associated to it. One of the things that you can do is we have redundant power supplies for ControlLogix. I generally don't recommend redundant power supplies on the chassis A, chassis B for redundancy, because you can always run 2 separate lines to those systems, but depending on your situation, you may need it. So just be aware of that. Typically, you see the I/O with the redundant power supply. What you'll see here is main thing that we have is usually a dedicated connection upstream. So this would be communication for the HMI, historian, data analytics, or potentially even from a maintenance point of view, your connection in here. Each Ethernet adapter that you add to the chassis can be in a completely different subnet. So that could be your segregation method based off the converged plant-wide Ethernet design that we put forth on how you do that separation, potentially via VLANs, the different switches, different systems, maybe a DCS versus the motor control center, things of that nature. One of the things that you guys should be aware of, if you haven't seen that in the design, is a swap over will happen from your primary to your secondary if you have a loss of power, if you change anything within the code, and also if you have a drop in communication on that chain. So what we typically see in these type of architectures, and what our recommendation is if you can have a Stratix, potentially maybe a 5700 switch dedicated directly to the chassis A, chassis B, have it separate, and then do your resilient network up top in maybe a redundant star topology or some type of ring topology. North of that, anything that happens at the distribution switch layer does not affect your redundancy swap over. So as long as this connection here is solid and this connection here, you won't see any intermittent swap over events. So it's typically why we try to have a dedicated switch up top. We do have architectures where you can support a device level ring or parallel redundancy on the upstream network directly, but typically this depends on how the overall system looks and how big the system is. So quick recommendation, you want at least 1 upstream segregated network in most cases. In a device level ring, you are looking at 50 node max, so 50 individual devices. Because of the fact that you can have multiple communication cards, you can support multiple nodes. We just have to watch out for the total number of connections capable within the controller that you choose. This will be true for both an L7 and an L8 style design. Some of the other things that you'll see here is on the device level network. So that is segregated from that traffic. So you have IO network versus your maintenance or your HMI traffic. You can support multi-mode fiber via the ETAPs. If you need to support single mode fiber, we would use the Stratix switches. Stratix switches are capable of supporting device level ring directly. So we can do this either as a 100 meg network, 1 gig network, fiber or copper. The only true recommendations there and requirements is don't mix and match your network type. So if you have a gig network, don't introduce the 100 meg network on the same chain. If you have multi-mode and single mode, that doesn't matter as much from a physical media perspective. The bigger issue there is your speed. So as soon as you introduce a 100 meg network into a gig type path, you drop everything to 100 meg. Essentially. Easiest way to, that's an oversimplification, but that's kind of what happens. Let's see. The other big piece there is we do have the ability of being able to introduce power. So when we're looking at the Rockwell VFD lineup or the Intelligent Motor Control Center through IntelliCenter, those all have static switches as part of it. We have dedicated designs as part of our architecture to make those resilient. Typically inside of the motor control centers, we would have one switch dedicated for multiple pieces of equipment. So at that level, that would still be a star design, but as you leave the Intelligent Motor Control Center, whether it's to redundant controllers or simplex controllers, we have ways of either doing that via redundant star, device level ring, or potentially even parallel redundancy at that level if we needed to. What you'll see here is different topologies. So this is a device level ring. The other example that I'm going to show you is doing redundancy via parallel redundancy. You can also have, again, redundant switches, redundant thin clients, and you even have the ability of being able to do NIC teaming on those, so you can have set dedicated pairs. As of V31, redundancy introduced an ability of having no swap over for ControlLogix when it comes to the IP addresses, which can heavily decrease the amount of what's called HMI blind time. So the amount of time that your FactoryTalk view system takes to be able to do the swap. For anybody that's not aware of what happens in redundancy, because we have a chassis A and chassis B, if you lose communication, you lose power to your chassis A, which is your primary, the secondary will take over. Traditionally speaking, what would happen is they would have the exact same IP address range. When they first synchronize, your primary will have the first octet. Your secondary will automatically take your octet +1. So if this was a .5, this would be a .6. As it would do the swap over and you lose your primary, the secondary then would turn into your primary and would go from that .6 back down to .5 so that it would match up and all of the IO has the same ability. We introduced in V31 the ability of having this as .5 and .6 without having the need for the swap over, but all of the IO will still handle that connection. So this was something that we added. It is not a requirement. It is not the default. You have the ability of being able to tie this in. This extremely helps on the HMI side where you essentially are tying in both connections at the same time as a primary, secondary, even inside of FactoryTalk view. If you guys need more information on that, it's in the manual, it's in the knowledge base, or just ask us. We can kind of work you through those type of networks. So that was device level ring. I know it's a lot. Hopefully we'll kind of get through in questions if you guys have it. The other example that I have here is parallel redundancy. So again, PRP for short. Very similar design. We'd still be having segregation between your upper level network where it comes like your upstream for the HMI historian communication, but then also segregation for your IO network. The IO network can be mix and match. So you can have ControlLogix or Flex IO. So as we introduce this as parallel redundancy, as I mentioned, so we support this with the EN2TP module inside of ControlLogix or the Flex 5000 that supports parallel redundancy. With an L7 design, this would be at minimum version 31. With the release of 33, you'll have the option there as well. So what we'll see here is the switches in between can act as both the standard switches. So what happens inside of parallel redundancy is any switch within LAN A and LAN B, this little kind of cloud that we're showing here, do not need to know anything about parallel redundancy. You're essentially creating a path that's isolated from each other. So from this number 1 to 3 to 4 or 3 to the IO, this never interacts with LAN B. It's a completely segregated path. You don't have to worry about it. These switches can be your standard switches. They don't have to be anything quote unquote special. Your standard Stratix 5700 switch is more than capable. As we incorporate any devices that don't natively support parallel redundancy, at this point, we would use what's called a redundancy box, or red box for short. This has to be a dedicated style switch. In terms of networking, it needs to be able to support what's called jumbo packets. So what we would see from a Rockwell topology is this would be our Stratix 5400. So the Stratix 5400 has the ability of being able to support parallel redundancy as a redundancy box. All that means is it's able to take non-parallel redundancy devices, tie it into the switch, and then communicate both to LAN A and LAN B at the same time. There's a smart port configuration inside of the switch that says, okay, port 7 and 8 are dedicated to LAN A and LAN B. So similar idea to what we've used ETAPs in the past for device level ring. Think of this as a big ETAP for parallel redundancy, but it has to be specific to the 5400 style switch. So we'd still have the same amount of nodes that tie in. The way that we handle this, essentially, as we start incorporating this, same thing here, as I mentioned. So we'd be adding the motor control centers because the individual devices here don't support parallel redundancy. We would use that redundancy box. So as we start adding this, whether it's OEM skids, package power, that would still be able to tie in. You'd still have your resilient network up top for a redundant star topology. Again, we can handle this and mix and match designations. So we can do redundant star or ring topologies, but you would have your dedicated communication. So you one for upstream, one for downstream. You still have your 7 cards that you're able to do. And you still have the ability of being able to do NIC teaming as we start seeing up top. The big change over here, as you guys have seen, device level ring has a 3 millisecond reconvergence time. So if you lose a network connectivity, it fixes itself within 3 milliseconds and you go to a linear network. Parallel redundancy has 0 reconvergence time. Essentially, it is a bumpless transfer. So if you lose a cable, you lose anything within LAN B, LAN A was still communicating and sending the data actively on both ports. So that is the big change. So we see this more in utility companies or any requirements that require a essentially no bumpless transfer when it comes to redundancy, whether it's from the communication or now in redundant ControlLogix. The last slide that I have here, and we'll take a couple of questions after this, is on the general guidance. One of the things that I will urge anybody that's doing redundancy, I oversimplify it. I make it sound, I hopefully make it sound simple. Inside of Studio 5000, turning on redundancy is essentially as easy as checking the box. You tell it you're going to use redundancy, it will automatically synchronize from your primary to your secondary. The main requirements, as I mentioned, is chassis A and chassis B have to be identical. No IO within the chassis, so you're just your controller, your Ethernet adapters, and then your redundancy module. They have to be the same firmware. You have to add the same program. As I mentioned, they will automatically assign the IP address as a +1 design if you have that as default. But one of the things I will urge you is there is a ControlLogix Redundancy User Manual. It has a checklist. It has documentation regarding how you approach it, how you program it, how you architect the system, the do's and don'ts inside of this. So, and it also still talks about Ethernet IP style designs, also ControlNet style designs. Even though I urge as many people as I can to move to Ethernet IP, if you still have a ControlNet style need in the L7 world, you can use the same redundancy module. All of the firmware, including the redundancy kits and the configuration and setup, all of that's handled via our PCDC, the Product Compatibility Download Center. So you just download the initial version, and then it just ties in based on the requirement of what version of Studio 5000 you're currently using. So it kind of goes without saying. I urge you to read the manual if needed. But if you run into any issues, feel free to reach out to any of us, whether it's from the Rockwell team or distribution. You know how to get a hold of us. As far as questions, Wayne, did you see anything that I might have missed?
Yeah, hold on. Let me look. I don't see any Q&A. Let's see on the chat.
I don't think there's been anything since Louis last answered.
Yep. Okay,
I
we'll
see
give everybody.
regarding FactoryTalk View version 12. I'm checking on that right now, but I believe we're looking at September timeframe. So they're not going to be matched up exactly. So I would probably expect version 33 of Studio 5000 to come out right before we start seeing it. Plant PAX 5.0, the system release, is essentially using V12. So I would assume as of right now, since we have a September release, those are going to be very similar timeframes, either within a couple of weeks. So we'll probably see all of these releases hit at the end of the summer, early fall, almost at the same time within a couple of weeks themselves, honestly.
So it looks like there was, just to kind of maybe elaborate a little better on the PLC5 and slick mapping, that aspect of it for the L8.
So essentially what you're going to see, as I mentioned, so the L8 in a redundant configuration will not support the IO directly. So what that means is, from a mapping point of view, you would have to tie in those controllers to another either simplex L8 system or a L7 style system, do the mapping at that level, and then you would have to do producer consumer from that external system to a new L8 redundancy system. Essentially, you're not going to be able to bridge. You won't be able to add that as part of your IO. So in the IO tree, it won't be a dedicated connection to the PLC5 or the SLIC. Hopefully that answers that. Question came in, when is FactoryTalk links used instead of RS links? The answer to that, realistically, at this point, is almost always. So we introduced FactoryTalk links as a change. It used to be called RS View 32. RS View Enterprise, sorry. Thinking something else in my head. So it used to be called RS View Enterprise. That was part of FactoryTalk View SE. Originally, it was only more from the HMI level to create a shortcut into the controllers. What they've done is, when they did the name change, they expanded on the services platform itself. So what we see there is RS links, while it's still there, is no longer our preferred method of communication to the controller or even to the HMI. That has now been taken over by FactoryTalk links. So FactoryTalk links now has all the capabilities that RS links had in terms of the Ethernet IP style connections, or the ability of being able to do even redundancy connections and everything else. So from a Studio 5000 point of view, as Chris mentioned earlier, V33 will now default to FactoryTalk links. The only time that you potentially see an RS links connection needed is when you have the needs for OPC connection, that old method of being able to communicate to DH plus or those topics. That would still be used there, since FactoryTalk links will be used primarily just for a Ethernet IP style design. But as far as communicating to a newer system and using everything, I would urge you to start looking at potentially moving over to a FactoryTalk links. There's no change licensing wise. It's still part of the same kind of packages. Any other questions, guys?
Looks like there's one on
Factory-
FactoryTalk. Yeah, you got it, Luis. Yep.
Yeah, I just saw it. So FactoryTalk Links has been out for quite a while. It will be, obviously it will be part of 33, but it is backwards compatible. So I'd say at this point, we're probably looking at anything 30 and above have already been using FactoryTalk Links. So it is backwards compatible. It is part of the services platform. So as you guys are aware, anytime you install anything that's Rockwell software, so that may be the HMI platform or even Studio 5000 services platform comes underneath. That's what handles the communication, the links drivers, the live data connection, and also how we handle security, the activations. All of that is part of the FactoryTalk services platform. So the ability that we've had inherent now to be able to read OPC UA natively, all of those type of things are part of the FactoryTalk services platform. FactoryTalk Links is the communication driver as part of that. So we've had that as kind of our mainstay for the last couple of years. What we've been hesitant to is getting rid of RS links or those type of architectures. With V32, V33, we're pushing a little closer to kind of urging everybody on to the FactoryTalk Links side of it. But what we've done is incorporated a lot of the RS Links feature sets into FactoryTalk Links now. Harold, we'll take it a little bit offline, but essentially, like I said, the L8 will not handle it directly. So all of that mapping will need to be done either from a simplex or L8 or a essentially a redundant L7 system. So that mapping will not exist as part of the L8 redundancy system. L8 simplex, yes, but L8 redundancy, that mapping will not be done there. But feel free to reach out to one of us so we can kind of work you through that and maybe look at the overall architecture that you're dealing with.
Okay. I guess we're a little past 11 o'clock, and I don't know see anything else coming in yet. So we'll want to thank again Luis and Chris for the presentation today. Very informative. And we want to thank everybody for joining us. And we'll post the slide deck and the recorded session will be posted to our user group archive page. So that'll be made available here shortly, maybe later today, or if not tomorrow. So thanks again, and we'll go ahead and we'll end our session.
Thank you, everyone.